This is number 4 from the 2000 exam. Okay, so we've got water being pumped into an underground tank at a constant rate of 8 gallons per minute. Then water is leaking out of the tank at a rate of radical T plus 1 gallons per minute. So what's important here is that they gave us two rates. We've got the domain 0 to 120 minutes, and at T equals 0, the tank contains 30 gallons of water. So how many gallons of water leak out of the tank from T equals 0 to T equals 3? Well, here is our rate at which the water is leaking out. So if we want to know the gallons, what we'll do is we'll integrate from 0 to 3 of T plus 1 to the 1/2. So let's do a little u sub. We're going to let u equal our inside function. du is dt. So we've got u to the 1/2 du, but we have to change our limits. So 0 plus 1, 0 plus 1 is 1, and 3 plus 1 is 4. We'll integrate. We've got u to the 3/2, 2/3 in front. So what do we have? We've got 2/3. 4 to the 3/2 is 8. So that's 14/3 as our answer. And this is in gallons. So part B, how many gallons of water are in the tank at time T equals 3 minutes? So for that part, we know we're starting off with 30 gallons. We are, let's see, what does it say? The rate at which the water is pumped into the tank is 8 gallons per minute. So it's 8 gallons per minute. We're talking about the first 3 minutes. And then we should subtract out our 14/3 that we got in part A. So this is, let's see, 54 minus 14/3. Need a common denominator. So we get 148/3 gallons. Part C, write an expression for A of T, the total number of gallons of water in the tank at time T. So B kind of helps us out with that. We know that the amount starts with 30. We're adding 8 gallons per minute, but then we've got to subtract out our integral, which looks like that. And then I think we're done with part C. Now we have part D. At what time is the amount of water in the tank a maximum? Okay, so let's take a look at some critical numbers here. We want to find out when A is a maximum, so let's take A prime of T. The derivative of 30 is 0. The derivative of 8t is 8. Now we're going to take the derivative of our integral, so that's the second fundamental theorem of calculus, which leaves us with a radical t plus 1. Let's set that equal to 0. And we get that t could be equal to 63. So this is our location for our only sign change, which means that we have a maximum or a minimum here. I'm going to use the second derivative test to determine which one. If this turns out to be a maximum, then that's our answer, but if it turns out to be a minimum, we've got to check those endpoints. So our second derivative, the derivative of 8 is 0. And let's see, we're going to get 1/2 t plus 1, which would be negative, to the negative 1/2. or negative 1 over 2 radical t plus 1. So our second derivative at 63, we get radical 64, which is negative 1 over 16, which is negative. Therefore, we have a maximum. T equals 63.